It's hard to bring cutting-edge science into the primary school classroom. Roche Pinner Primary School's answer to the problem was to invite STEM ambassador Clare Davy into their school.
Hi, my name's Clare Davy and I work here at the National Institute for Medical Research. I work on papillomaviruses, trying to understand these viruses that can cause cervical cancer.
Claire finds out how viruses work and how they affect the cells in our bodies. By learning more about these viruses, Claire is doing important work that can help to cure and prevent diseases.
So what I'm looking at down the microscope is some human cells.
After infecting cells with virus DNA, the cells are stained in different colours. These colours let Claire see easily which parts of the cells the virus has infected.
My epiphany was when I was aged 11 and somebody gave me a piece of magnesium and a Bunsen burner, and the thing goes off like a rocket, and that was me. I was hooked, and that's my career now.
Keen to share her passion with the next generation of scientists, Claire is a STEM ambassador, one of many throughout the country who work with school pupils, broadening their experience of science, technology, engineering and mathematics.
There's this huge bank of STEM ambassadors who are really keen to go out to schools, and they have a lot of resources that the schools don't have, so they have access to funding and equipment that could really benefit the schools. It's nice for the children to also meet people who are actually doing real jobs and not just science teachers.
Roche Pinner Primary School has asked Claire to run a science activity for their Year 6 class. Claire has been in charge of many events before with a range of ages, but every school is different, so where possible, a face-to-face meeting beforehand is an excellent way to make sure that the day will run smoothly and the activity will be pitched at the right level.
I think if schools want the event to be as successful as possible, then they have to provide as much information as possible to the STEM ambassador. So the ages of the children, roughly their abilities, what sort of space is available to hold the activity in, and also roughly what they've been studying maybe that year.
Claire has a discussion with class teacher Emma Levine so that they can theme the day around an engaging story that will capture the pupils' imagination.
So normally when we're doing this activity with the older children, we set up a crime scene that's a murder, but I think maybe for the Year 6s that's not appropriate.
No, I would agree with that one.
Do you have an idea of some other type of crime that would be appropriate to put on?
Yeah, we could do something that goes missing. We could have a jar of sweets, for example, that we were going to give to the children, but they could vanish and we need to work out who the thief is.
And who do you think would be a good person for them to relate to in terms of who the suspects might be?
I don't mind, you could always use me, and I'm sure Mrs. Freeman, our teaching assistant, would be happy to get involved.
The story will be that both Miss Levine and Mrs. Freeman were seen in the vicinity of the crime. Also, the sweet-toothed thief has left skin and hair at the crime scene. Claire will help the pupils to analyse DNA from these samples to see if it matches either of their suspects.
DNA is obviously a really important aspect of our lives, so for them to have a basic understanding of what it is, then when they come to hear the term DNA, at least now they'll know a bit more about it.
For the class to catch the culprit, Claire must teach them a bit about DNA. DNA is an exciting topic which can inspire pupils about science and give them a taste of what they can learn in the future. But it's also an advanced topic which is difficult for Year 6 pupils to understand. Claire's solution is to use the crime story as a hook to get them involved.
Do you think your students will know anything about DNA already?
They may have heard of the term DNA, but it's not something that we study in Year 6. It's not in the curriculum, so I think it'll be something that's really exciting for them to learn about.
What have you been looking at recently?
We are just finishing up looking at microbes.
And microbes, that's good as well, because I work with viruses, so I'll be able to tie in my work with what they've been looking at recently.
Wonderful.
If you use the right vocabulary and you use the right analogies, they understand it very easily. And because they're so enthusiastic about learning what it is you're telling them, it's actually quite easy to get your message across.
It's the big day, and Miss Levine's Year 6 class have come back from assembly to find their classroom is a crime scene. Luckily, Claire and her colleague have come to coach the class to catch the confectionery criminal.
The first thing I'd like you to do is to think about cake, OK? Now, I love cake. Who else likes cake? Right. What's your favourite type of cake?
Chocolate.
And how about you?
Fudge cake.
If you were going to make your favourite type of cake, how would you know what to put in it? What would you have to look at? A recipe, OK. But what about humans? Is there a recipe for making you? Well, there is, and it's called DNA.
Clare tells the pupils that everyone has DNA in every cell of their bodies, and because everyone's DNA is unique, it can be used to catch criminals.
Don't you normally use fingerprints to find out crime?
OK, so if you're a criminal and you think you might be caught because of your fingerprints, what could you do?
Oh, you could wear gloves.
You could wear gloves, OK, so it's really easy to stop the police getting your fingerprints.
Now that they know a bit about DNA, the class splits into groups and completes a range of activities to suss out the sweet-stealing suspects.
So if they touch the crime scene, then pieces of skin might come off their hands, and skin is made of cells, and so the cells contain DNA. So what else might be found at a crime scene? Yes?
Hair?
Hair, yeah, OK, so hair also contains DNA.
One group are making models of the suspect's DNA. The DNA models can be stretched out to form a long ladder, and the important information is held in the rungs down the middle of the ladder. The different coloured beads represent different molecules, and the pattern of those colours in the middle forms a unique sequence for each person.
What's C is blue? We need 2 blues. Put these 2 together. No, it's not. 2 blues? Yeah. There you go.
Having engaging hands-on activities means the children are easily getting to grips with the complexities of DNA.
I think all the children understood what DNA was and why it's important and where it comes from. And on a basic level, it definitely is not too hard for them to understand.
Once the pupils have completed models of the suspect's DNA, they must now split up the long chain wherever a certain pattern of colours occurs. They can then use the sizes of these fragments to compare the suspect's DNA with DNA found at the crime scene.
So now we have to work out how big these pieces of DNA are.
1, 2, 3, 4, 5, 7.
Yep.
1, 2, 3, 4.
Yep.
And 3.
That's right.
The activities aren't only about science. Where possible, Clare has incorporated a range of subjects and skills, including literacy, art and numeracy.
So how far down there have you measured?
2.7 centimetres.
OK, and how do you know it should be 2.7 centimetres?
This 3 bins is 5.
Yep,
And 5 equals 2.7 centimetres.
that's right.
With a love of science from such a young age, it's not surprising that Clare's enthusiasm for the subject spills through into her other interests.
I really like cooking, which I think is just kind of science that you end up eating. I also like music, so I'm currently teaching myself to play piano, and there are a few other instruments that I've played quite badly in the past.
As part of her job, Clare uses a technique called gel electrophoresis to analyse DNA from viruses. A small amount of prepared DNA is carefully placed onto a slab of special gel and an electric current is applied. The current flows through the gel for over half an hour, and this splits the DNA into its component parts. One of the benefits of a visit from a STEM ambassador is a chance to use professional equipment that's not normally available to the school. Clare has brought along the gel electrophoresis equipment so that as well as working with their DNA models, pupils can also see how DNA would be analysed in a real laboratory.
So you've got to have a really steady hand for doing this, so who thinks that they're going to be able to do that? OK. Oh, wow, first time all of it in. Well done. That was better than mine.
Gel electrophoresis has separated the DNA out into several fragments, just as the pupils split up their models of DNA into fragments. Large fragments find it harder to move through the gel, so they don't travel as far as smaller fragments.
Who can tell me which piece of DNA is the smallest? Yes.
The yellow,
And why do you think the yellow is the smallest?
because it's moving the fastest.
That's right, it's the smallest, so it can get through the gel really easily, so it's moving fastest and therefore it moves furthest.
I enjoyed today because we got to do loads of experiments and investigate DNA.
So I had fun doing all the art and doing the gel over there.
I enjoyed today because I learned a bit about DNA, which I had no idea about before.
Clare's activities have really got the pupils thinking about science and DNA. Having a practicing scientist come into schools means that the pupils have a chance to pick her brains with the questions that they have.
Did dinosaurs have DNA?
Dinosaurs did have DNA. If we had access to their DNA, then people say we might be able to make dinosaurs. But the problem is, not only do you need the recipe for making a dinosaur, you'd also need a mummy to make the dinosaur in. And since we don't have any mummy dinosaurs, it's unlikely, at least for the time being, that we'll have any baby dinosaurs. I'm hoping that it will enthuse some of them to go on to study science further. But more importantly, I'm hoping that it will enthuse all of them to go home and talk about science with their family and friends.
All the big questions in science, like time travel and cloning.
Yeah, OK, so cloning is when you can make exact copies. Do you think that's a good idea?
No.
Why don't you think it's a good idea?
It might be good on animals to get more food.
Yeah, what about cloning humans? Is that a good idea?
No.
No, OK, so that could cause problems, couldn't it?
With Clare's visit nearly over, there's one last question that needs to be answered.
But now the big question is, who do you think stole the sweets? 1, 2, 3.
I never thought she would take them because she's really nice.
I was really shocked because I never would have thought it was her.
I enjoyed being one of the suspects. It was all a bit of fun, and I think the children quite liked it.
Although the children might have thought it was me, but of course it was Miss Levine.
I was really pleased with the activities today. The kids were really great. They were very enthusiastic. They were very knowledgeable. They were great at answering questions and coming up with questions for me.
I think they could relate to a lot of things regarding some of the TV programmes that they watch. So DNA is something that they're quite used to hearing, but obviously they didn't know what it was until today.
The activity was a great success. The children initially had no real idea about what DNA was, and by the end of it they were all really enthusiastic. They learned a lot, they had a lot of fun.
I didn't actually know that science could be so fun and interesting.
Today was much more fun than normal lessons because we got to express ourselves more and learn a lot more than we would have done in a proper science lesson.
And in a normal science lesson, then we would do experiments, but not like this, with goggles and gloves and lab coats.
When I asked the children if they could see themselves maybe being a scientist one day, I got a lot of yes answers, and I think maybe we've converted a few of them to becoming scientists.
I'd probably like to be a scientist because it looks really fun and everything that happens in it is just amazing.